Data, like all things, has a beginning, a middle, and an end. We call this the data lifecycle. The first phase of the data lifecycle is the creation of data. Data can be created in many ways, e.g., from a paper form, an image, electronic documents such as Word or Excel, or from a database. Data is typically created by an organization in one of three ways: through data acquisition, which is acquiring existing data which may have been produced outside of your organization; by data entry, which is manual entry of new data by staff within your organization; or from data capture, capture of data generated by devices used in the organization. Once data has been created, it must be stored in a format that is secure, yet easily accessible by those who need it. The second stage is data curation. Not all data is immediately usable. Often it needs to be analysed, cleansed to correct any data quality issues, and standardised to make it useful. Identifying data quality issues and correcting them is covered later in this course. The third phase is data consumption. Now that the data has been prepared, it is now ready for use. Data may be viewed on screen, in printed reports, on dashboards, and in spreadsheets or other documents. Access to confidential, sensitive, or personal data should be secured so that only people who need to use the data have access, with defined processes to obtain access when required. An audit trail of access and use of data should be maintained to ensure that data is used appropriately. The final phase is dispose. As data ages, it becomes less useful and therefore less valuable. Once data is no longer of use, it should be deleted. In addition, the Australian privacy laws stipulate that personal data should be deleted when it is no longer of use. Data that is accumulated over a period of time can consume a lot of storage space, which is expensive to purchase and maintain, and cause information systems to slow down and become less responsive. So it's best practice to delete old data. How do you know what old data is? That's a decision your organization needs to make. It should have a policy that explains what data should be deleted and on what conditions. Talk to your IT department or head of information management to find out more. So far, we've taken a look at data, what it means, and how it is used. But how do we know if our data is good enough? The answer lies in the 8 dimensions of data quality. While there is no single definition of data quality, i.e. no official standard, data is considered to be of high quality if the consumer accepts that it is fit for the purpose it was collected for. This is a very subjective view, as one person may view a set of data as being acceptable, while another may not. This is why there is now a large body of data quality research aimed specifically at providing a systematic approach to determine whether or not data is fit for purpose. These are described as the 8 dimensions of data quality. The first dimension is accuracy. This is the degree to which data resembles and reflects the real world. If data has been captured on a form and then transcribed into an information system, accuracy is how close the transcribed data matches the data on the form. This may be represented as a count of correct data items or a percentage of the total, e.g. 6 out of 10 or 60% of data elements are correct. That might be an acceptable number for the purpose it was collected for, but generally speaking, we aim to achieve as close to 100% accuracy as possible. The second dimension is availability and accessibility. This is the speed at which data is made available for use and the ease to which it can be obtained. If data is stored in such a way that it takes too long to gain access to, then this may lead to risks. Again, this is a subjective view. What is an acceptable time frame is dependent on a number of factors including size, volume, and distance from the consumer. Ultimately, it's up to the consumer to define what is an acceptable time frame. Some applications of data require it to be available immediately, while others can wait a day or so. The requirements for the speed of data delivery and how the consumer wants to access it will affect the choice of delivery mechanism. The third dimension is completeness. This is the degree to which data matches its real-world object and covers the real-world object. For example, if you had a data collection form to gather information about a person, and the person leaves some of the boxes blank, we call these null values, then we might encounter difficulties when it comes time to process the form. For example, if the form was collecting patient demographics and the patient doesn't write their date of birth, then we won't know their age. If the patient doesn't write their Medicare card number, then we won't know if they are eligible for Medicare. This has an effect then on finance, as they are unable to bill for the service and the hospital suffers a loss of revenue. The challenge with completeness is It may be complete enough for your use, but may not be complete enough for other uses. Again, we can measure completeness as a count of completed fields or percentage, e.g. 60% of fields were completed which did not have blank or null values. The fourth dimension is consistency. This is measured by the degree to which data is unique across multiple sources. For example, if we are dealing with customers, then we should only have one record of each customer, unless there is a reason for duplication. If the data exists in more than one place, then consistency is the degree to which they align, e.g. are similar. The degree of alignment can be represented as a count of fields that align, or a percentage. The fifth dimension is currency. As mentioned earlier in the course, data reduces in value as it ages, so for data to remain useful, it must be up to date with any changes. The sixth dimension is reliability and credibility. Data is considered reliable if it comes from a trusted source that is well known and understood, all of which dictates the degree to which the data can be trusted. Data is considered reliable if it can be tracked back to its source and that any calculations or changes, i.e. transformations, of data is visible. Some data can be validated against external reliable sources. Some examples include vehicle registrations can be checked against state-based registration systems. Driver's license details can be checked the same way. Doctor's registration and credentials can be checked online. These sources help confirm the reliability and credibility of the data. The seventh dimension is usability and interpretability. Data is collected for a specific purpose, and the key consumer may confirm it's usable, while a secondary consumer may not be able to use it because it doesn't meet their needs. The degree to which data can be used is therefore specified as a result of this. As an example, a doctor's diagnosis and treatment notes are of no value to finance, as they require this information to be standardized in order to use it. This is the role of clinical coders, and if the clinical coding is not complete or accurate, then it will be of little use by finance for billing, as they lack the capability to interpret medical notes accurately. This will then cause hospital to not receive any or the full amount of income that would otherwise lead to loss of revenue. The eighth dimension is validity. If a data item was calculated from other data, then the calculation must be correct and must be using the correct data item. This is where the degree to which data aligns with known business rules is crucial. For example, you might own a service company that delivers to customers within a 10-kilometre radius from the depot. You'll need to include a business rule that checks customer addresses during the sales process to ensure they live within the service area. This would need to include the course of actions when a customer is too far away, e.g., do you make the customer pay more for a courier, or do you tell the customer to come and collect it themselves? Or maybe you just tell the customer you're unable to help them. Which would you choose? In summary, as you can see, there is a lot more to data quality than is it right? We have taken a high-level look at the 8 dimensions of data quality that can assist in determining if the data is fit for purpose. In the next module, we will take a closer look at each dimension. Congratulations, you've made it to the end of the first module. Let's do a quick recap. Data is everywhere and comes from real-world objects. The context of data is required in order for it to be useful. We describe data using metadata. Data becomes more valuable the more it is used. Data equals information equals knowledge equals wisdom. Data often has primary and secondary use. Data has a beginning, a middle, and an end, which we describe as the data lifecycle. Data is considered of high quality only if it is fit for the purpose it was collected.